Good morning and good afternoon to everyone. I'm very happy to see that so many of you joined us today. So we are going to talk about serverless on Kubernetes services using virtual nodes capability. I have Rishikesh here and Fernando, who will be your presenters in this session, and they will tell you more about what is it that you will going to see today. Thing from my side, and then I will invite our presenters to say a few things about themselves. Keep in mind that for today, everything you see has an educational scope. So in case any one of you would like to watch any of our sessions and of course would like to use our services in the future, you may contact the Oracle account team. Also, our products are enhanced on a regular basis. So in case anyone would like to watch these sessions in the future, keep in mind that you might see some small differences within the Cloud Console menu. As I said at the beginning, this session is also showcasing a cool demo that Fernando will do. So if you have an Oracle account, you may take this journey together with us. That was all on my side. Rishi, would you like to step in?
Thank you, Violeta. Thank you so much, everyone, for joining us today. My name is Rishikesh Palve. I'm part of product management team in Oracle Cloud Infrastructure. I particularly focus on containers and Kubernetes services. And I'm joined by my colleague, Fernando, from Cloud Native Application Development Specialist too. Today, we are going to talk about how you can simplify Kubernetes operations at scale with the new capabilities that we've added in our managed Kubernetes offering called OKE. So let's get started. I'll quickly walk you through the agenda for today's session. We'll start by talking about the momentum that Kubernetes has gathered. Then we'll talk about how our managed Kubernetes offering OKE simplifies Kubernetes operations. And we'll dive deeper into the new capabilities that we have introduced, particularly OKE virtual nodes that deliver serverless Kubernetes experience. Fernando will walk us through a demo of virtual nodes, and then we'll talk about other new features, add-on lifecycle management, workload identity, and finally, we'll open up for Q&A. So before I get started, I would like to bring up the first poll just to understand how you've been adopting containers and Kubernetes. Violeta, can we bring up the first poll, please?
Sure, on my way. Can you guys see it?
Yes.
Perfect. So let's save like 40 seconds or so to allow our customers to answer these questions. And then we can go further.
Yes. So responses are coming in. Perfect. Okay. They're still coming in. Let's give a few more seconds.
Sure. Pretty good answers, I could add.
Yeah, this is great. All right. So looks like we have about 50% who have been using containers in production, about 42% who have been using Kubernetes. And then the third question that we had was the top challenges in using Kubernetes. So steep learning curve, about 24%, managing and scaling Kubernetes cluster infrastructure, about 28%. A few people are also facing challenges with Kubernetes version upgrades, and then cost and security. Perfect. This aligns very well with our understanding of how customers have been using containers and Kubernetes as well. All right. So let me go ahead and let's talk about the Kubernetes momentum. So I believe many of you, at least 50% of you said you've been using Kubernetes. So you know what Kubernetes is. For those who don't know what Kubernetes is, it's an open source system for automating deployment, scaling, and management of containerized applications. If you have been following this space, a few years ago, there were multiple tools that were used for managing containerized applications. However, today, Kubernetes is kind of de facto way of managing containerized applications in cloud and on premises. It is almost synonymous with cloud native application development and application modernization. It has become that most popular technology in the overall stack for cloud native application development. And over the years, use cases for Kubernetes have expanded beyond applications, including auxiliary workloads and IT operations as well. So how popular is Kubernetes really? After Linux, Kubernetes is the fastest growing project in the history of open source software. And majority of enterprises are in the process of adopting Kubernetes. According to Gartner, more than 90% of enterprises will be using containers in production by 2026. And of course, developers love cloud native and Kubernetes in particular. According to this survey by Slashdot, there are more than 7.1 million cloud native developers globally. And this is 67% increase in just 1 year. So with that introduction to Kubernetes and Kubernetes momentum, let's understand how we simplify Kubernetes operations. As we talk to our customers, one of the key challenges customers have with adopting Kubernetes is the complexity of operations. And in the poll, we saw how it's difficult to manage the underlying Kubernetes infrastructure, day to operations in particular, patching your infrastructure, operating systems, scaling that infrastructure, or upgrading Kubernetes versions. All these operational complexities and the steep learning curve of Kubernetes make it difficult for organizations to adopt Kubernetes. And that's why we have started seeing this shift towards managed Kubernetes offering. And this is where our Oracle Cloud Container Engine for Kubernetes, or OK as it is popularly known, is helping our customers simplify and accelerate adoption of Kubernetes. This is managed Kubernetes service provided in Oracle Cloud Infrastructure. It is built on open standards. It is 100% compliant with upstream open source Kubernetes. In fact, it is CNCF certified Kubernetes conformant, which means you can easily port workloads from other Kubernetes environments to OKE without having to change those workloads. It provides built-in management. So with OK, you get fully managed Kubernetes cluster control plane. And for your data plane where the workloads are actually hosted, you have options to choose between managed nodes. These are highly managed VM or VM instances provided in your tenancy or customer tenancy. Or you can choose to use the new virtual nodes capability that we've added that provides fully managed Kubernetes cluster data plane, so you get a complete serverless experience for Kubernetes. One of the key differentiators for OK service is its superior price performance. It is built on OCI's flexible infrastructure that provides flexible shapes, giving you ability to choose the right size for your resources. If you compare it with other cloud providers, you would get at least 3 times better price performance with OCI's compute, and OK service is built on OCI compute layer. So you get the advantage of superior price performance with OKE as well. OK service is by default highly available. So the cluster control planes that are provisioned as part of your clusters, they are highly available, spread across different availability domains by default. You do not have to do any additional configuration for that. Then one of the key tenets of Oracle Cloud Infrastructure is built-in security at no additional cost. And OK integrates Kubernetes with the security controls that are provided by default in the Oracle Cloud Infrastructure. So some of the examples include private Kubernetes clusters, image signing, scanning, encryption, and so on. OK is also compliant with various industry standards and specifications such as PCI DSS, SOC, HIPAA, and many more. When it comes to deployment flexibility, OKE supports multiple types of compute shapes, and it allows you to create heterogeneous clusters. What this means is you can create an OKE cluster with, for example, GPU shapes as well as x86 shapes, and run workloads depending upon the type of workload on different types of shapes in the same cluster. So you get the unified management experience for different types of workloads in the same cluster. Also, OKE, as all other OCI services, is available in a dedicated region cloud at customer, or DRCC. So you get the complete portfolio of OCI services in your data center, including OKE. And finally, since it is built on open source, it's easy to extend your Kubernetes or OKE clusters. You can choose to leverage the Kubernetes operators that we provide for Oracle technologies such as database, WebLogic, or you can use any third-party Kubernetes extensions and bring them to your OKE clusters. And now we have made it even further easier and simple for you to use Kubernetes with the new capabilities that we've added to OKE. We have added support for OKE virtual nodes that deliver serverless Kubernetes experience, and we'll dive deeper into this in a bit. In addition to that, we've added a feature called add-on lifecycle management that simplifies installation and configuration of operational software on Kubernetes clusters, popularly known as Kubernetes cluster add-ons. While OCI provides fully managed experience for managing the add-ons, it also gives you control and flexibility in terms of how these add-ons are managed. And finally, we've enhanced the security further by providing strong workload isolation with virtual nodes, as well as by adding a new feature called as workload identity for fine-grained access control. Now, with the introduction to these new features, let's dive deeper into OKE virtual nodes that deliver serverless Kubernetes experience. As I mentioned earlier, we now have two types of nodes in OKE: managed nodes and virtual nodes. The Kubernetes cluster control plane is fully managed, whether you're using managed nodes or virtual nodes. When you choose to use managed nodes, the nodes are provisioned as compute instances in customer tenancy, which means some of the operational responsibilities for the Kubernetes cluster data plane are shared between Oracle and customers. Customers are particularly responsible for managing the underlying compute resources, scaling those resources for managing the capacity in the cluster data plane, and also upgrading the Kubernetes data plane components. On the other hand, if you choose to use virtual nodes, you get fully managed control plane as well as fully managed data plane so that you can focus on building your Kubernetes applications. On the next slide, I'll explain in more detail how virtual nodes deliver a serverless Kubernetes experience. So as I was saying earlier, you get fully managed control plane and fully managed data plane. So you don't have to worry about managing the underlying Kubernetes cluster infrastructure. You don't have to worry about scaling the capacity in your data planes. And you also do not have to worry about upgrading the Kubernetes components. So virtual nodes are designed to deliver serverless Kubernetes experience. They abstract the physical worker nodes in Kubernetes clusters. And by abstracting these physical worker nodes, they simplify infrastructure management and scaling for you. In fact, OCI or the OKE service manages infrastructure management, scaling, and Kubernetes version upgrades for you. So this significantly simplifies Kubernetes operations. As a user, you do not have to manage any infrastructure. You do not have to manage capacity or scale the capacity. As you deploy Kubernetes applications on your clusters, OK virtual nodes will dynamically provision right-size compute for your pods. And as number of pods grow, it will automatically provision more compute for your applications. So it simplifies scaling. It also provides seamless Kubernetes upgrade experience, and we'll talk about upgrade experience in more detail later in this presentation. While it provides fully managed experience and simplifies Kubernetes operations, it does not compromise on the flexibility that you should have for your applications. So you still have flexibility to choose the underlying compute or processor shape. For example, you can choose AMD E3, E4 shapes while creating virtual nodes. You also get high vertical scalability. What this means is you can allocate all the CPU and memory resources to a pod. For example, for E3 or E4 AMD shapes, you can allocate up to 128 virtual CPUs and 1 TB of memory per pod. So if you have intensive workloads and you want to run them in serverless pods, there is no constraint on maximum CPU or memory limit at the pod level. You can use all the resources that are provided by the underlying compute shape. OK virtual nodes also support topology spread constraints so that you can ensure your pods are distributed across different availability and fault domains, and you have highly available deployment for your applications. It enhances security posture of workloads running in Kubernetes clusters. It does that by providing strong isolation for each pod. Every pod is isolated from all other pods at the hypervisor level. So you get VM level strong isolation for every pod. A pod does not share underlying operating system, kernel, CPU, or memory with other pods. So this gives you a very strong isolation for your workloads. It is also integrated with OCI's virtual cloud network so that you can ensure network security and isolation for your workloads as well, leveraging the capabilities of virtual cloud network. And finally, OK virtual nodes help you optimize the cost of workloads and the underlying compute for running those workloads in your Kubernetes clusters. So when you are using OK virtual nodes, you're only paying for the CPU memory resources allocated to your Kubernetes pods, and you pay at the same price as underlying compute. This is different than how other serverless Kubernetes offerings price their products. You would typically pay a higher CPU or memory price when you're running serverless pods. However, with OK, you pay at the same price as compute. So there is no additional CPU or memory charge for the serverless experience. We do charge a small management fee per virtual node. However, it's a nominal charge. And when you are running Kubernetes at scale, you would see this is insignificant compared to the cost optimization that you would get with OK virtual nodes. In fact, we have published a blog post that does comparison of Kubernetes costs across multiple cloud providers. And towards the end of this session, we'll share the link to that blog in useful resources. Now let's quickly understand high-level component architecture of OK clusters with both managed nodes and virtual nodes. So when you are using managed nodes, of course, the control plane is fully managed and it's in OK service tenancy. So it's managed by the OK service. And when you are creating a pool of managed nodes, those nodes are provisioned as OCI compute instances. It could be virtual machines or bare metal in your tenancy in your virtual cloud network. So you are responsible for managing the data plane operations for your managed nodes. You get Kubernetes API endpoints in your virtual cloud network through which you can access the Kubernetes cluster and manage and deploy workloads using the Kubernetes API endpoint. You can expose Kubernetes pods via Kubernetes services or ingress, and these are also created in virtual cloud network. Now let's compare this with virtual nodes. Kubernetes cluster control plane is still the same. So the way you access Kubernetes cluster via Kubernetes API endpoint is the same. When you're creating a pool of virtual nodes, those virtual nodes are also created in OKE service tenancy. So OKE service manages the virtual node pool. And as you are deploying applications, it dynamically provisions compute for executing or running the Kubernetes pods. Each pod is connected to a virtual networking interface, using which you can expose pods as Kubernetes services or ingress, exactly the same way how you would do it on managed nodes. So the way you interact with Kubernetes clusters and way you manage your applications or on Kubernetes remains the same. However, with virtual nodes, you get fully managed experience for your cluster data plane as well. So to summarize, with OKE virtual nodes, we eliminate Kubernetes cluster node lifecycle management for you and give several hours back to your engineering teams every day. You do not have to worry about managing node capacity. You do not have to worry about node repairs or patching operating system. And we provide fully managed seamless upgrades for all the Kubernetes components across control plane and data plane. Today, we provide a semi-managed experience with managed nodes. However, we are also planning to provide fully managed experience for managed nodes upgrade as well. Now let's quickly understand how you manage capacity and pay for that capacity with managed nodes and virtual nodes. So with managed nodes, you manage the CPU and memory capacity of the nodes at the node pool level. So if you want to increase or decrease the capacity in your managed node pool, you would either manually add or remove nodes, or you can configure cluster autoscaler to automatically increase or decrease the number of nodes. And you pay for the CPU and memory allocated to your nodes, that is compute instances, which means you pay for the VMs or bare metal instances. With virtual nodes, you specify CPU and memory configuration in your Kubernetes pod specification. So you specify it in your deployment configuration, and virtual nodes take care of provisioning the right-sized compute based on the CPU memory that you've defined in your deployment configuration. So that completely eliminates the need to manage capacity in your data plane. Virtual nodes will take care of provisioning the capacity, and you pay for the CPU memory resources that are allocated to the pods. So it removes the problem of paying for the resources that are not getting utilized on your nodes. So with that overview of virtual nodes, let me turn it to Fernando to walk us through a demo of virtual nodes.
Thank you, Rishikesh. I'm trying to share my screen. Let me know when you can actually see it.
Yeah, I can see it.
Yeah, nice, thank you. So as Rishikesh already introduced me, I'm from the Cloud Native Application Development Specialist team for EMEA. I'm Fernando Harris. The idea here in terms of a demo, it's supposed to be an operational demo, right? This serverless virtual nodes is a great operational feature with the main goal of simplifying administration tasks and operational tasks for the different engineering teams, and kind of helping the development teams playing around and using Kubernetes to turn the focus to the application design and application development, and not so much for the infrastructure management. Okay, so this demo, actually, we have part will be live, and another segment will be, it's actually recorded because we needed more time to actually show it. So we have 3 points here, 3 different scenarios, let's call it like that, to share with you. A first one, which is not more than the very act of provisioning the cluster and selecting the type of nodes that you want to use. Some of you are already using Kubernetes in Oracle Cloud, OKE, and you're probably familiar with it, with the console and how you actually use the console to create a cluster. I would like to remember and to remind that you can actually use the OCI APIs to do the exact same type of exercise which we are going to do here, right? If you want to use curl or Postman to replicate this type of exercise. But as I was saying, this first bullet is the act of provisioning the cluster and the different node types. Then we have a second scenario. We are going to deploy the MuShop app, which is an application you have available to explore OCI. It's a microservices-based application, and you can actually use it and use its code to deploy different OCI services. And we're basically going to see how to deploy that and to what with the objective to in the final scenario to see how you can actually use auto scale with virtual nodes, and in this case with the MuShop application, to see how you can actually see in this case the MuShop application reacting to an increase in demand of resources usage or utilization, how it scales automatically, how it scales the automatically to react to the different need of CPUs and memory and so on and so forth. And you can actually see how the pods are actually getting created and how the application guarantees or assures its resilience through the virtual nodes and in the auto scaling. Okay, so let's start. I'll keep these pods like that, and I'll move to my tenancy here, my OCI tenancy. For those of you never used, if you go to oracle.com, you have immediately access to the cloud, the Oracle Cloud infrastructure. Once logged in, you can actually explore your console. There are a lot of services covering all the way from application development and development services, as we are going to see, to data management, artificial intelligence, machine learning, data management, database management. In this case, we are going to put our focus on the developer services. Inside the developer services, you'll see a lot of services, including integration services, as I said, some transversal or horizontal developer resources, which you can use for infrastructure as code, for configuration management, for low-code development, for DevOps, for CICD setup. But in this case, we are focused on this cloud-native reality. So we should be more or less looking into the container and the artifacts and functions as well. It's important to say that Oracle also has a serverless function service. In this case, here in containers and artifacts, Kubernetes clusters, OKE, is what we want to see. As you probably noticed already, inside these containers and artifacts, we have other important services such as the container instances, which in terms of the internal topology of the virtual node is very important. Rishikesh, maybe he can share some details about these later in the discussion follow-up. But container instances are actually very important to understand how the virtual nodes actually work behind the scenes. Then you also have a container registry to manage the life cycle of your Docker images of your containers. And finally, you have artifacts registry and service mesh as well, right? As a native service to OCI, if you are deploying a microservice architecture, for instance, and you need a mesh, you can use service mesh, okay? From OCI, you can use other mesh approaches, but you have these ready and available to use here, okay? So what we want to do now is to create a cluster, which is basically click this button here. But before creating the cluster, let's actually look. I have a couple of clusters here created. I have this cluster test chaos, which is a normal managed, a cluster with normal managed nodes. And then I have this cluster serverless. If I click, you can actually see how it looks at the end, right? So in this case, the name is cluster serverless, and maybe relevant to some of the things that Rishikesh mentioned, right? The network type the relationship, the very close relationship between the cluster and the OCI networking constructs, which allows you to have a few important features to increase isolation, to increase your ability to route, your ability to protect your routes, your traffic internally, but here probably more importantly to share the node pools. In this case, I have a single node pool. You can see it's called pool 1, node type virtual. And I created this with a single ID. I'm working on the London region. But I have already here 3 virtual nodes, worker nodes created, right? They are private. They are in active state. And one thing that is really interesting, probably to share as well, when you can see that there is a new version available. Rishikesh mentioned that one of the benefits is also in terms of managing the upgrades, the Kubernetes upgrades. In this case, we don't have to worry in terms of to drain and to prepare the different node pools and to choose an approach, a strategy to do this type of upgrade. We don't have to we still have some concerns, but not that type of concern. What we have to be to know how to use is basically to decide whenever we want to upgrade for a new version of Kubernetes, as this would be the case of this cluster, right? I can have this synchronized between the cluster version and the virtual node, right? So, and the effort in terms of managing the upgrades is quite reduced, okay, as well. So let's get back here to clusters again, and let's create a cluster like this one, right? As you are probably aware, there are 2 different methods to create a cluster, an OKE cluster. You can use the first one, which is this quick create, and as you can imagine, there is a lot of things already prepared for you, a lot of resources already included. A lot of these resources are network related, right? So, and you have these ready, as you click, you have it ready to use, right? And then you have the custom create option, which is the right approach when you want, for instance, you need a very customized approach, or you want to kind of extend your local data center networking. So it kind of adjusts better to more personalized use cases. In this case, for this exercise, we are going to use the quick create option, and let's see what happens. So when I decide to create a cluster, I'll have this interface here where I can give it a name, right? I can call it cluster 3 demo, serverless again, okay? The compartment where I'm going to create it, and in this case, my personal compartment inside my tenancy, okay? The Kubernetes version, typically you have some retrocompatibility, at least 2 or 3 versions behind, right? So you have 25, 24, 23 years still available. You can use the 26. And then important, the way I'm going to expose my kube API endpoint on my cluster control plane. So in this case, if I opt for a private endpoint, you assure that your kube API will be hosted on a private subnet, and the public endpoint, the kube API endpoint will be on a public subnet. And finally, we get to the node types, right? So this is where this new feature is actually, it becomes visible. Let's say it like that. If we follow the previous approach, which was the manage node types, as you can see, we have some constraints and some concerns regarding the worker nodes and the way these worker nodes, for instance, are going to be exposed, if they are private, if they are public. And most importantly, we have concerns regarding, and Rishikesh emphasized that very well, the capacity management concerns, right? So, and depending on the nature of the workloads that we intend to run on OKE, on any Kubernetes managed server, actually, this might imply the way we actually do and execute the capacity management might imply some effort and preparation and estimation, right, of resources to ensure that the capacity that we are defining and eventually provisioning is going to be enough And this is the type of rationale which will have financial implications, but also, and probably more importantly, operational implications. Because if not done properly, we will have capacity management negatively impacting the resiliency of our system as a whole, right? So we don't want that to happen. And also, as Rishikesh mentioned, this is one of the cases. The other case is that you actually are requesting capacity that you are not going to use, right? So you need to balance these. You need to know when it's too much or when it's not enough. So this is a concern, right, for the operation teams. And so when you are actually setting up your managed worker nodes, you decide basically here the shape and the image, right? You have different types of shapes and images, bare metal, VMs, dense, etc. You can, if you are working with flexible images, you can define the number of CPUs and then the amount of memory you are going to use, okay, besides the image of the operating system and the node count, of course. Now, with virtual nodes, the new feature, right, your focus will be completely different. It's a change of paradigm, right? So in this case, all the capacity management concerns are quite reduced and simplified, right? What is also simplified is the typical Kubernetes operations, as I already mentioned, Kubernetes upgrades, scalability, the demand variation, which will impact the traffic, might impact the traffic and might impact the amount of resources that your nodes will need to use. All those concerns are simplified. That narrative, let's call it like that, is simplified, and this removes a lot of the pains that operational teams typically have. So in this case, all I have to worry is I decide for virtual worker nodes, right? And I can decide, I still can decide the number of nodes I want to run inside the node pool. And also, this is important in terms of, for instance, in terms of distribution across different availability domains, right? So it's still relevant in terms of high availability, of course. And finally, in terms of pod shape, as Rishikesh explained, I can choose the pod shape, which kind of will adjust exactly to the number of resources, to the amount of resources I'll need to run my pod, right? And I will pay. This is very important. I'll pay only for the resources I'm using. So I'm not going to pay for available capacity that I'm never going to use. So at the end of this process, I can basically decide to create a cluster. I will have this resume, right? And I can create a cluster, and I will have this summary. I hope I still have account available. Yeah, I still have, I'm under my service limits. So and the cluster would be created, right? This is exactly what we are going to show here in a few seconds. This takes a few minutes to create. Here we can see in these recording the exact same steps I've just showed. So we create a cluster, we submit, we choose we help for the virtual node type, and eventually the cluster with the 3 nodes will get created, right? That summary I explained before, and it's kind of accelerated, and the cluster will become available first, and then the virtual worker nodes will quickly also become available. In this case, a node pool with 3 nodes, virtual nodes with their private IPs, right, and their Kubernetes version, right? This is what you need to do to create a cluster, right? I remind you again that you can do this with the API as well. So then the second step, the second scenario was basically to deploy the application. And this new shop application is a simple application where you can find it in OCI when you're playing around with the tenancy. It's that available for you to explore in Oracle GitHub as well. And once the application is deployed, this will launch a series of deployments and a series of pods, okay? And you will be able to see that here you see the container are being creating, the pods are being launched, are being scheduled, okay? And once they are ready, you'll be able to see that here in the dashboard, in the Kubernetes dashboard, okay? We have 6 deployments, 6 pods, and what is also relevant, the new shop makes available a few services, internal and also external ones. In this case, the external one, which is relevant here for the explanation, just to see how it looks like the application. Let me see. Okay. Here in services, you'll see an edge service, a service called Edge, which is of load balancer type. You can see here the IP, the cluster IP of it as well. And this is the front end of these microservice application, right? Made of different microservices. And that's pretty much that, right? You can see now here that we have at the end, at exactly the end of this recording, you can actually see. I can show that in the beginning, so of the next section. So the auto scaling of the mu shop will show us how the virtual node will react to an increase in demand of the application, right? You saw, you can actually see here the actual CPU usage and memory usage, right? And we know that we have those 6 pods running, and at some point we launch a specific application, a specific pod, which will load the microservice mu shop application to make it a scale, right? To start using more resources, and which will imply a scaling, right? A scale up in this case. So you can actually see here the different moments, right? You can actually see that at some point when you start seeing a variation in the CPU usage, and you also start seeing new pods getting created here, okay, below, right? And at some point, you will see that the threshold of as time goes by, right? You can actually see the increased threshold, like the threshold variation, the threshold of the CPU, right? And eventually the memory as well. So you can also see the number of pods increasing. You can actually scale to really interesting operational, new operational limits. And eventually you'll have the CPU usage at a different level, right? You can see how it scales and with the auto scaling setup, and the number of pods all the way to 333, right? So very quickly, this is just a very quick and simple way to show how this can impact your operational tasks, not just in terms of what I mentioned, upgrading the Kubernetes, etc., and not having the need to think as much in terms of capacity management, and also the way the auto scaling feature from Kubernetes works very well with the virtual nodes in terms of responding automatically and dynamically to an increase and a decrease in the demand to use the application. Okay, this was what I had to show here. Rishikesh, back to you, please.
Thank you, Fernando. That was great. Let me go ahead and share my screen again. All right. Okay, now what I want to talk about is how OK Virtual Nodes simplify the Kubernetes upgrade experience for you. So with OK Virtual Nodes, the cluster upgrade is a single-click operation. If you remember, Fernando was showing that button, new Kubernetes version was available. Once you click that and select the Kubernetes version, all the upgrade process happens automatically in the background for you. So at first, it would upgrade cluster control plane and virtual nodes without...
Rishi, you're just sharing the wrong screen, dude. You're sharing the kind of developer screen.
Oh, okay. Let me go ahead and try to share again.
Not that it matters, Mike, but just in case.
Do you see
that's it?
Okay,
perfect.
Thank you for that. So as I was saying, you get single-click experience. Once you start the Kubernetes cluster upgrade, cluster control plane and virtual nodes are upgraded automatically without disrupting any of your Kubernetes pods. Then it would upgrade the kube proxy component running on your pods asynchronously with minimal impact on your workloads. And to ensure minimal impact, virtual nodes would respect the pod disruption budget that you've configured for virtual nodes. So that's how the overall Kubernetes upgrade experience is simplified. All the Kubernetes components across control plane and data plane are upgraded in a seamless way. Now, I want to talk about the other new features that we've added to OKE that further simplify Kubernetes operations experience for you. So let's talk about add-on lifecycle management first. So with add-ons, lifecycle management feature, we provide, so OCI manages the full lifecycle of the operational software that you install on OKE clusters, and you still have control over the add-ons that are running on your clusters. By add-ons, I'm referring to the Kubernetes operational software such as kubeproxy, core DNS, CNI that you would install on your clusters. These are typically essential software add-ons that you would install for running your clusters. In addition to that, you can also leverage a growing portfolio of optional software such as Oracle Database Operator or Kubernetes Dashboard and many more to leverage the extensibility that's offered by these optional software. With add-on lifecycle management, users can install or disable specific add-ons. You can also choose specific versions to be installed, and you can opt in or opt out of the automatic upgrades that are performed by OCI. So you can choose to let OCI manage the updates completely, or if you have any compliance requirements or specific requirements, you can choose to install a specific version and update them based on your needs. Rather than showing or explaining this on a slide, let me quickly show you a demo of how this works. I hope you are able to see OCI console.
Yep, all good.
So I've already created a cluster. Fernando created a cluster with virtual node pool. I have created a cluster with managed node pool. In the cluster, once you go to add-ons, you'll see the add-ons that are already enabled for the cluster. Core DNS, Flannel, that is overlay CNI, and kubeproxy. These add-ons were installed by default when I created the cluster. Now let me click on manage add-ons and show how you can manage add-ons. So currently we have created a curated portfolio of these add-ons, and we have plans to add more add-ons in the future to this catalog. Let's say I now want to install a Cert Manager component. It's a popular open source software for managing certificates in Kubernetes clusters. All I need to do is enable Cert Manager. If I want, I can use the default automatic updates so that I don't have to worry about updating versions of Cert Manager as and when new versions are released. Or if I want to install a specific version, I can choose to install a specific version. You can also additionally provide configuration such as node selectors for node affinity, tolerations for temps and tolerations, and you can also specify a number of replicas that you want to install. I'll select the default automatic updates option and save changes. As you can see, it has started deploying the Cert Manager component on my cluster. So that's how you can easily manage add-ons on your OKE cluster using add-on lifecycle management. Now let me talk about the other feature that we've added, Kubernetes workload identity. This feature is for improving security posture by providing fine-grained access control. So using workload identity feature, you can apply the principle of least privilege to your Kubernetes workloads by authorizing specific pods to access other OCI resources, such as object storage or database. So this improves the overall security posture because you're authorizing only specific pods rather than creating policies at the node level or using Kubernetes secrets to inject credentials for accessing OCI resources. So combined with the pod level isolation of virtual nodes, and the fine-grained access control that's provided by Kubernetes workload identity, it becomes easier to run multi-tenant workloads on OKE clusters. You have fewer clusters to manage since you have pod level control, and overall total cost of operation is also lowered, leveraging virtual nodes and the superior OCI compute that it runs on. In addition to that, we've added a bunch of other improvements to OKE. We now provide financially backed SLAs for control plane availability. So you get financially backed SLAs for your Kubernetes cluster control planes, which means we now provide even more reliability and guarantee to run your control planes in highly available configuration. We've also added support for preemptible compute instances for managed nodes. This is particularly useful to optimize cost when you're running interruptible workloads. Those workloads can take advantage of 50% lower cost compared to running on-demand instances. And we've also increased the default node limit for OKE clusters to support larger cluster sizes. So now we support 2,000 nodes per OKE cluster. This is double the previous limit that we had. And we also provide an option to increase the number of nodes beyond the default limit. To summarize, we've added several new capabilities in OKE, focusing on simplifying Kubernetes operations at scale. With these new capabilities, you can lower the total cost of operation by reducing the time, cost, and effort needed to run your Kubernetes. Leveraging the managed capabilities, you can accelerate adoption of Kubernetes in your organization. And of course, you can improve developer productivity by having them focus on their applications rather than managing underlying infrastructure. Now, before I pass it to Violeta, I want to cover this topic. And I believe it came up in questions as well. With the spectrum of options that we provide in terms of runtimes for your applications, where do you run your workloads in Oracle Cloud Infrastructure? And that depends on the control or level of control or agility that you want when you are delivering your applications. So on the right-hand side, you'll see high control options. If you want to have control over underlying infrastructure, as well as operating system, and you don't have workloads that are containerized yet, or you want to lift and shift your existing applications, you can directly run those workloads on OCI compute. If you are planning to use, or if you're already using Kubernetes, you can leverage OKE to get the power of Kubernetes for automating deployment, management, and scaling of your containerized applications. And you can choose between managed nodes and virtual nodes, depending upon the control and agility that you want. If you don't want to worry about underlying infrastructure at all, you should go with virtual nodes. And we expect majority of users would use virtual nodes unless they have specific requirements in terms of underlying compute configuration or operating system. Those are the use cases where you would leverage managed nodes. In terms of running or use cases that you can run on managed nodes versus virtual nodes, you can run any containerized applications. Virtual nodes in particular are useful for spiky or bursty workloads. Currently, we don't have support for persistent volumes. However, in the future, we are planning to add that support as well. So you would be able to run stateful workload as well as specialized workloads on virtual nodes as well once we add support for persistent volumes and GPU shapes. Fernando briefly mentioned OCI container instances. This is another serverless compute service that we provide. This is designed for running containers specifically without managing any underlying infrastructure. Now, what's the difference between OCI container instances and OKE virtual nodes? With OCI container instances, you don't get the complexity of Kubernetes. So if you have applications that do not require Kubernetes or the advanced container orchestration capabilities of Kubernetes, and you need a simple, quick, and easy way to run containers in the cloud. For example, if you are running Docker containers on premises or on VMs, you can easily move those workloads to OCI container instances, and you don't have to provision any VMs to run your containers. On the right-hand side with OCI functions, you get more agility because you're writing code and deploying that code, which is fully managed by OCI functions. So functions are typically useful for running short-lived workloads that you want to be triggered by events. So for event-driven workloads in particular, or workloads that are triggered by APIs and executed for short duration, you can leverage OCI functions. With that, I'm gonna pass it back to Violeta to conclude the session. Thank you.
Well, with that, I would like to thank you all for staying until the end of this session and for being here together with us. Thank you, Rishi and Fernando, for presenting. And of course, we are more than happy to see you all in upcoming events. Thank you and enjoy the rest of the day. Bye-bye.
Thank you.